Hey everybody, it's your buddy Jay. Welcome back to AzureFunBytes, and we get together when? Every Thursday, 2 p.m. Eastern, 11 a.m. in the Pacific. And this week we're not on Learn TV, but we will be back on Learn TV next week. If you're wondering why, there's .NET Conf going on right now. There's gonna be a ton of content that you can follow up with for .NET Conf after the conference itself. But like I said, next week we will be back here on Learn TV, where we will have our normal situation with polls and chats and things like that. But obviously this week we don't. So I'd ask, if you're watching and you want to comment, you want to leave questions, go ahead, pop it in the YouTube or the Twitch chat. I'd love to hear from you because we've got a really great subject today. And so to get started on what our subject is today, it's Cosmos DB. And so before I introduce our guests, let's learn a little bit about what our guest is going to talk about in Cosmos DB.
Imagine a horizontally scalable database that puts data everywhere your users are. It seems intuitive, but most databases are still light years away from true turnkey global distribution. Azure Cosmos DB offers the first globally distributed multi-model database service for building planet-scale apps. It's been powering Microsoft's internet-scale services for years, and now it's ready to launch yours. Only Azure Cosmos DB makes global distribution turnkey. You can add Azure locations to your database anywhere across the world at any time with a single click. Azure Cosmos DB will seamlessly replicate your data and make it highly available. Azure Cosmos DB allows you to scale throughput and storage elastically and globally. You only pay for the throughput and storage you need, anywhere in the world at any time. As the first and only schema-agnostic database, Azure Cosmos DB automatically indexes all your data so you can perform blazing fast queries. And since no data is born relational, the multi-model and multi-API capabilities remove the friction, allowing you to build with any data model and API. While most database services force you to choose between strong or eventual consistency, Azure Cosmos DB provides multiple, well-defined, intuitive consistency choices, so you can select just the right one for your app. Take off with confidence, knowing Azure Cosmos DB provides guarantees and comprehensive SLAs other databases would never attempt. High availability, consistency, throughput, and single-digit millisecond latencies at the 99th percentile. Your app deserves a globally distributed database service that's out of this world. Welcome to Azure Cosmos DB.
And to help us discuss Azure Cosmos DB today, I bring to you someone that is a principal product manager on the team, someone that I'm really happy to have here. It's Mark Brown. Hey, Mark, how are you today?
Hey, Jay, how you doing?
I'm doing well. You know, I'm really excited to talk about Cosmos DB. And I'm really glad that you were here to help me out with it today, because there's definitely a lot of questions that I know our viewers are going to want to have answered. And I think without them asking them, you're going to answer a lot of them, because you've already got a lot of great stuff lined up for us.
Yeah. I'm happy to be here. It's and I love talking about Cosmos. So thanks. Thanks for having me.
I want to first ask, you're a principal program manager at Microsoft. How did you wind up here?
Gosh. Well, I mean, I joined Microsoft over 20 years ago. Was working at a .com back in the original .com days. And I don't know how I ended up here, actually, but I've been with Microsoft for almost 21 years now, or almost 20 years, I guess. And I've been in Azure going back to 2011, I think, is when I joined that team. When it basically happened when Scott Guthrie took over Azure. I worked on the web platform and tools team. So we did web platform installer. Silverlight was on our team as well, all that stuff. So when he took over Azure, I moved over into Azure. And
Very cool.
Ever since. So, I mean, I've been on a bunch of teams. I worked on the Antares or web apps team. Was their PMM for that team, and then networking. And now I've been on Cosmos for about 3 years, and this is the most fun I've ever had. Working working on a distributed database is just good geeky fun, basically. Right?
Yeah, if you love cap theorem, if you love learning about consistency and replication, and latency, of course. But there's a lot of things that happen in the background that I think you're going to be able to give us some answers around with Cosmos DB. What's funny is yesterday we were on Hello World, which is like a daily show on Learn TV. And we talked a little bit yesterday about what exactly Cosmos is and how it stands out from other big databases as a services out there, because one, it was born on Azure. It was born on Azure, and it made a decision to be a lot of things to a lot of people. And so when we call it a multi-model database, what do you tell me a little bit about that?
Sure. So at its heart, Cosmos has what we call our core API, or better known as our SQL API. But we have an internal structure, if you will, for how we store and serve data within there. And then we also have these other layers that we emulate, these endpoints that emulate other APIs or database APIs.
So Leaf here that's listed, Gremlin,
Cassandra. That's Mongo,
table.
actually. The Leaf is just meant to represent the graphic that we can't basically use.
Sure.
So we emulate these other layers like MongoDB. So it understands native Mongo commands. And then there's a Cassandra API, and that understands CQL. And then Gremlin API that understands the Gremlin spec. And then there's a table API as well. So
sure, we can see over there at the bottom, we've got our different actual data types, like key value, which is almost the most simple when you're thinking about document style, or JSON, if you will. Key value is kind of the base of JSON. Column family, documents end up being huge because you can put so much different types of unstructured data and then index on all of it. And then graph, which is really tremendous for doing analysis and getting big visualization of what things are.
Yeah, for relationships, right? So it's which is graph excels at. So
absolutely. So before we kind of get into what you'd like to show us, I want to make sure everyone knows you've got something really cool coming up in a couple of weeks that everybody should kind of keep their eyes open on for. It's about a month and a half, actually. It's Azure DB, Azure Cosmos DB Conf. Is this your first?
It is. So I've been wanting to do this for maybe a year or two, but it's our first stab at trying to do kind of a live conference and run it in multiple time zones. I thought about doing it for like a continuous 24 hours, but it's I don't think we're quite there yet, being able to run and execute a continuous 24-hour event, kind of like Jeff does for the .NET.
Mm-hmm.
I mean, that's not even 24 hours. That's like 3 days.
Yeah.
So we're not quite to that.
I feel like there's so much in Cosmos that even a full day that you're coming up with like a 9 to 5 kind of program or something like that, you still can just put so much into it.
So we're going to run 3-hour streams, and we'll do it at kind of an America's time zone friendly, and then an Asia Pacific, Australia time zone friendly, and then a Europe and Africa time zone friendly. So 3 different streams over that kind of 24-hour period. And then I want to have people local to those areas, talk about Cosmos and share and make it a more of a community kind of effort or conference, if you will. So anyway, so that coming up in April, we're super excited. I'm busy getting all the planning and everything with that, and partnering up with the Learn TV folks as well, who are helping us through this. So excited.
Very good squad, and a very good squad of people. And one of the best parts about Learn TV is the ability to reach a big audience that all are really interested in learning a lot about this content. And so with that, why don't we start getting really into what Cosmos is. Like we touched on it a bit.
I got some slides, and I figure, slides are a
Sure.
good way to kind of describe Cosmos. And I can talk over this. And what I want to do is kind of give people kind of a grounding for, what is Cosmos, and help understand some kind of the basic concepts here. So, officially Cosmos is, we're Microsoft's NoSQL database in Azure. But what I mean by that really is it's my slide isn't working.
When you do it, you do it live, right?
I know. Hold on. Let me move some
No
stuff.
problem. I'll give you a second.
There we go.
Anyway,
it's that what I want to say is it's NoSQL. What we mean is it's non-relational, and it's also horizontally scalable. So let me break that down. Basically, with horizontal scalability, it's different than, say, a relational database where you've got, you basically do scale up. So if you need additional throughput or capacity, you scale up into a larger VM. With horizontally scalable, you basically just keep adding servers to that, right? And so basically when you're talking to Cosmos, you're talking to a cluster of servers in there. And what's nice about this is that with a scale out database, you can practically have unlimited amount of storage in there, right? I mean, theoretically, the amount of storage you can have in this type of database is infinite, right? Or just bounded by how many servers you can have in a data center, if you will, or an Azure cloud. The other cool thing about this too is as you keep adding servers, you can increase the throughput, which means you can process more data, right? And do that all at the same time because they're all going to different servers, if you will, right? So there's kind of a theoretical, or there's a limit, if you will, for uncharted databases or uncharted relational databases that now they can do because they can do sharding and stuff. But this type of database is designed to work that way. And so, as you add more servers, you can increase storage or you can increase the number of servers to increase your throughput capacity with that. And then the other thing is it's a non-relational data store. So when you were obviously working with something like a SQL Server or MySQL or Postgres, you have these kind of relational concepts like being able to do foreign keys or be able to define constraints and do joins across those things. With a database like Cosmos, you can't actually do this kind of stuff, right? And the reason is because we're this kind of horizontally scalable database, and it's while it's how do I say this? I mean, it's feasible technically to do that type of thing, but from a performance aspect, it actually is a killer. And with a database like Cosmos, the thing we really shoot for is to be predictable in terms of that performance. So that's not something that we want to do is to put locks on data that sits on a different server, if you will. One of the other things I wanted to talk about is throughput, and we can kind of get into RUs. I know we were talking about RUs earlier and how kind of confusing they are as a concept for folks. But let me kind of explain throughput, because basically this is kind of what RUs are. And we have these two different models. There's a provision throughput model, and then there's a serverless model. So with standard throughput, let me start with that first. That's kind of similar to what a VM is, if you will, right? Like you are provisioning some amount of compute and storage, if you will. For us, it's obviously on the compute. So you provision that and then you use it, right? And you get billed for it no matter how much you use or don't use. Just like a VM would work, right? You could provision a huge VM and then play solitaire on it. That doesn't make any sense, right? You want to consume and use that throughput. Now you can change throughput with Cosmos. But there's kind of some limits there. Like you can't go from like 400 RU to like 1 million RU instantly. Just like you can't provision a new VM like that instantly. Now you can move throughput up and down, and we'll adjust that instantly for like smaller amounts. But if you go into major amounts, that's difficult because we still have to provision the compute behind that to provide that throughput. Autoscale is different. And we announced to release this last year. And the way this works is you set what your maximum amount of throughput is, and then we will automatically scale that up or down from 10%, from the max that you set down to 10% of what your max is. And what's cool about Autoscale for Cosmos is kind of unlike compute autoscale that takes a while to respond or to scale up. this is instantaneous behind the scenes. So you don't have to worry about any lag if your demand goes up, that you have to wait for resources to go and be ready for you. So this is a good model for folks that they have bursty workloads, or if they're unpredictable and they don't want to get rate limited. Autoscale is a great model. And then the last one is serverless, and we announced this last year, and we're still in preview on this. But basically, this is just pay for what you use, right? It's per request type pricing in there. So this is really cool. And for like very bursty workloads that have like a bunch of activity and then nothing at all for a while, this is a good option for folks. So this is great, right? Like when I joined the team 3 years ago, we only had standard throughput in there. And what we recognized is that people have different workloads, and something like a standard throughput doesn't work for everyone. And so we started, coming out with these different types of ways to do throughput, if you will, with Cosmos. So this is great. We're really happy to have now Autoscale and serverless. We're definitely seeing a lot of adoption and usage because it makes sense for customers and how they want to use Cosmos.
So what would be like our use case for standard as compared? Because I can understand Autoscale where maybe we have an application that we, understand that there's going to be a certain amount of consistent throughput. And we're prepping for when it bursts aside from that consistent throughput. Whereas standard, I'm just guessing that that you're just staying in one spot and you're waiting for someone to manually provision additional replicas. Am I kind of going right or wrong?
Yeah, well, so with standard, I would say that the use case is that it's more predictable, right? Okay. So if let's say you have an app and it gets, and you deployed it in your company and it gets a lot of use during working hours and then not a lot at night. You could use the standard throughput and then just basically schedule. You could create like a little Azure function on a timer and then have it scale it up like an hour or 10 minutes or whatever before everybody comes into work, and then scale it down at night, right? That would be a good use case. And people do use that. In fact, I wrote a little utility that has a couple of Azure functions, and then it scales up and down databases or containers, and you can add a bunch of them in there, and then just run it on a schedule as an Azure function. That's going to be your best option there. You can create little things that monitor, like with the Azure Monitor today. You could actually monitor your usage. Now it's going to lag by 5 minutes because it's Azure Monitor, but you could create something and then write an alert. I think you could do this today and then have that trigger something that could increase throughput or decrease throughput based upon what's being used. So you could probably today even create your own little, Autoscale if you want, but it would lag, right? So
Autoscale. Are there existing triggers that you modify for Autoscale?
Existing triggers? No, I mean it's all handled in the back.
Okay, so you don't have to create triggers like you would say in like a VM Autoscale.
No, you don't do anything. You just say I want to use Autoscale, set whatever you want your max to be, and then that's it. You're done.
And with serverless, I'd imagine that's great for per process kind of. So let's think of I don't know, maybe an email collection list that you want to store the emails in a JSON doc and be able to grab those to put it into some sort of other format. I would imagine that serverless, maybe with like a static web app. So like a static web app or a one-page JavaScript app with maybe some sort of Azure function that collects information and brings it to that database. I would think that that combination of like the front end, not having to write the back end services with like a function, and then the database that the three of them would just I look at it as something that would just completely reduce overhead by using services. And so I just think that's a really good practical use case. And we have a question about the serverless free tier. Is there going to be one for Cosmos DB? Do you know something about that yet? Should we keep our eyes open? Not sure yet.
We got a free tier now.
For the serverless?
No, for serverless, no. For regular provision throughput, we do. Not for
Gotcha. And serverless is still in preview. So that comes with what Azure provides as far as preview of our services. So it's still really super useful for you to use. And to be honest with you, probably save you a lot more money And that's a big thing in all this. So I'm. You want to continue, Mark?
Yeah. So more stuff that I wanted to talk about with Cosmos is, and this is something that is confusing to folks at first because they're not used to using distributed databases. But one of the things that's important to understand is when you're building an app, a distributed app that is using a distributed database, there's these these two computer theorems come into play. And one of them is called CAP theorem. And what CAP theorem says is that if you have a distributed database and the network connection between them gets cut, you have a choice, if you will, between providing availability for your database. So basically, you can still read data from that database, or you have a choice for having consistent data in both of those different nodes in your database. And what that means is that if I can't give you consistent data completely, then I can't take any writes in the database. So this affects availability, if you will, right? So there's a choice here. I can stay available, but I may not be consistent because I can't see the latest writes from my other node in that database, or I can keep that data consistent. So this is a trade-off, and people don't fully understand, I guess, that. And I see this sometimes with people that say, I want to run in multiple regions, and I definitely need strong consistency. And then I said, okay, but if you do that, you may sacrifice availability if, say, one of those regions goes down. And they're like, well, why is that? And I said, because if you're going to provide consistent guarantees, and I can't provide, keep that data consistent, then I can't take any more data, which means it's not available. And this often makes people scratch their heads in some cases. But it's an important concept to understand. And then the other side of this is what's called PAC-LC theorem, which is CAP theorem. But there's another condition here, and that is even if your network and your database is able to communicate with each other, you actually have another choice you have to make, which is a trade-off between latency and consistency. And what that describes is that if I want completely consistent data in my database, I have to commit it to every single node in the database before I can recognize it as being committed. And because these nodes can be separated by large distances, you have to, and because it goes over a WAN, the trade-off is that your operations take longer, right? Because packets have to go over a network, right? And in some cases, if you have a replica in if you have a node in, say, the US and another one in Europe, you can have hundreds of milliseconds of latency in there. So as you try to write data to it, the what it looks like is your application runs very slow because it has to write locally, replicate it, commit it, and then ACK it back, right? So if you have 150 milliseconds of latency between, say, East US and Europe, that's 300 seconds. 300 milliseconds of total latency for each time you write to the database, which is a lot. And a lot of applications sometimes don't like that. So there's... Would
you call this an ACID compliant database for people, and maybe just define ACID for a second?
So we do have, ACID, yeah, of course. So ACID is, kind of defines the semantics around a transaction, if you will, right? And there you got a Wikipedia article there. There you go. So you can go look that up. We do provide consistency, like in an ACID, but it's on a per partition basis within a logical partition. And I can actually show you a transaction a little bit later. I have some demo code I can walk through that'll show you how I can do a transaction, if you will, but it's scoped to a logical partition within Cosmos, right? So remember, we can't provide kind of the same kind of things that you can do in a relational database because we're spread across these different physical servers, or partitions, we call them. Within Cosmos. So we scope things like transactions to a logical partition, which sits one or more in a physical partition, because that's running on the same physical server, right?
Very, very cool.
So, but consistency here doesn't mean ACID. It's a different, what it means is that the data is the same in all of the different nodes within the database, all of the different regions within the database.
So if you have your database replicated in like West US, the data should be as consistent as the in East US. The whole point is to make sure that using these consistency models gives you the best throughput for your database that you're expecting.
Right. And that's a great segue, because the other thing I wanted to talk about is the way you kind of dial this up and down is with the consistency models. And as your video kind of stated, most other cloud databases provide a strong or eventual, which is basically two ends of the spectrum, if you will. And of course, there's trade-offs, right? Like anything in distributed computing, there's a trade-off involved with these things. And so as you go up and down kind of this slider, if you will, there's trade-offs from consistency. They're stronger or weaker, higher or lower latency, and higher and lower throughput. So it's important to understand that that these trade-offs exist, and also what your application or the system or service that you're designing, what can it tolerate? What kind of behavior do you want to see out of that? Like if you have a requirement that says, and actually I'll talk about this in a minute, so I won't go there. But what's important to understand is each of these things kind of provides a sliding scale, if you will, between these things. Most people, I find, when they say they want strong consistency, actually what they really mean is I want to see my own rights, right?
Okay.
And that actually is something we can give them with what we call session consistency, which provides read your own right guarantees in there. And we do that with the use of the session token that essentially provides an LSN or a high watermark for the data that you've written into Cosmos. And then you just pass that token back and forth, and that will always guarantee that you will get the data that you wrote within there. Bounded staleness provides, as the name implies, it bounds the amount of staleness you see, and that's either through either an amount of time or a number of updates within there. So that's important for some people. Consistent prefix is a weaker level of consistency, so you get higher throughput, but the writes you see are always going to be in order, which is good. And then eventual is the weakest consistency, and there's no guarantee for anything in there, but you get the best throughput. So if you're trying to Firehose data, it's the fastest, right? Because it's not worried about the replication necessarily. It's really worried about just ingesting data. So
sure, I'd imagine that'd be really important to me if I was doing something like pixel tracking data. Like if I wanted to keep my eyes on what pixels people mouse over or touch on their screen. And you're giving kind of like that location and what actual things they clicked on. That's so much data all at once. And the other thing I like to think about is, say, like a ride service application. Like, when you hail a car and your latitude and longitude, and the fact that you can have to kind of keep those databases up to date constantly per second with where everything is located to be able to do some traceback and data analysis. And so being able to fire hose that all in and then worry about consistency later seems like a common kind of model.
Yep. So last thing I wanted to say about kind of consistency and cap theorem and all that stuff is this trade-off between availability and consistency is actually translated into two common terms you see, which is RPO and RTO, right? And RPO, or recovery point objective, basically it says how much data loss can I tolerate, right? And of course, both of these are a function of time, right? And then RTO is recovery time objective is how long are you down for, right? And each of those things is basically something that, as you chose a consistency level, is kind of what you're dialing up and down on. So if you have an RPO of 0, you can't tolerate any data loss at all, then you, by definition, have to use strong consistency within your database. The problem with that is that you're going to sacrifice availability. This is what cap theorem says, right? You can't have consistent data in a distributed data store. It's just cap theorem says you can't do it, and it's physically impossible. And then there's RTO, is basically how long are you down for. Is also,
and these are all CIOs across the world when they ask, how are we going to store our data? What's going to happen when we go down? And like on our website goes down or our database is unavailable. What's the recovery? And I think a lot about RPO and RTO in the idea of backups. And I know that one of the cool things about working with Cosmos DB is that's another thing that underneath the hood, you're having done for you. And you can set how often, when, where. And that in itself, I think, is really important, because if we don't back up our data and we don't have it, we could be dead in the water.
Mhm.
Our entire application could be almost useless if we don't have the data that goes alongside what we're trying to provide to
Right.
our end users.
Right. Yeah. So that's kind of it for kind of the distributed database stuff. There was one thing I wanted to talk about, which is related to Cosmos, and that's this new service offering we announced last year, which is Azure Synapse Link. This is great because what this is it provides what we call hybrid transactional analytical processing, or HTAP. How this works is it's basically for doing kind of big analytics on Cosmos DB data. And so kind of how this works is as you write data or we ingest data into Cosmos DB, we automatically ETL that into a column store. And then that column store then can be communicated or connected to by Azure Synapse. And you can then run queries on your Cosmos data using either Spark or SQL in there. And by the way, there's support for Mongo as well, right? So how cool is this? I can have MongoDB, ingest MongoDB data, and then write SQL queries on top of that, right? So
that's huge. And I knew, I worked at that database company for a little bit, and the thing I remember is having to use additional tools on top of MongoDB to run those SQL queries, because some people, to be honest with you, they just don't know how to write them in that MongoDB language or query language. And then while that MQL, it reads a lot like English, let's be honest, SQL, what is it, like a 30-year-old type of database model? We've been working with it for so long.
SQL is 50 years old now.
50, excuse me.
1951. It came out in 1970. So,
and one of the cool things that I wanted to kind of show people really fast, and I think it's kind of one of the better things that we can say right out the gate about using Cosmos DB, is that a lot of people have. A lot of companies that rely on availability. Chipotle, you're ready for a burrito? Yeah. Well, they're going to help that website kind of come together using .NET, Core, Visual Studio Code, and Cosmos DB on the back end. And so I thought that was a really cool kind of story. You can go to our website if you wanted to read that. I think it's always great to have like use cases from people that really give you an idea of what exactly people are doing with these tools. I love the functional thing. And so before we get into what you want to show us next, which I'm sure we got some great demos coming up. The one thing that's in there that I really thought was interesting that I wanted to make sure we all shared is they're using Visual Studio Code for a lot of what they're building. And much like a lot of the other Azure tools, Visual Studio Code has an extension for Cosmos DB. If you just kind of go in here, you can go to databases. And if you go to the Azure Databases extension, you'll see the ability to use Cosmos DB auto completion for all these different types. You can actually go into the database and create one. Right within here, you can get information on the event and even have what I believe is a local emulator for Cosmos DB. If I'm right, we provide like a utility that you can download and install locally and like mimic what you would do live in production. Am I right?
Yeah, we have an emulator. You can go to our, just search up Cosmos DB on our docs, or just actually I think you just type in Cosmos DB emulator and search results. Right there, and then you can download it and run it.
Yeah, let me put it all up here for everybody.
That's the ultimate feature here, by the way.
Yes, absolutely. So if you want to use the emulator, let me get you all the link. It's right here on the docs page. So you can go to the install and emulate Azure Cosmos DB for local development and testing. And, we want to run things through our testing suite, whatever we're using. And while we're doing that, we want to actually make sure that we can retrieve our data. So I think it's a really useful tool. So, Mark, you've got some stuff to show me now.
Yeah,
some functional coding, and so I'd love to go
beyond the conceptual stuff. I wanted to kind of get you, show some of your viewers kind of like some hands-on stuff. Like if they wanted to start messing around with Cosmos DB and playing around with it, just some of the stuff will hopefully make their kind of journey a little easier. So I wanted to show off a few things in here. So this is our Data Explorer in the portal, and I've got an account in here. This is one I use for and even some of the demos here for a talk I give about how to model and partition data in Cosmos DB. So what this is actually AdventureWorks 2017 database, and this is a subset of it. So it's kind of an e-commerce application. And what I do is in this talk I give, I go through successive iterations of this thing, because modeling data and understanding how to partition it is something of an iterative exercise. You don't just start like drawing like on an ER diagram and modeling your entities. It's more involved. You have to understand how your app functions and how it uses data to model your data. So you have to start with kind of your entities definitions, but then understanding how they're used in your database is actually how you should think about modeling. So this here is just basically straight up entities, right? I just took the tables and imported them. And then I go through successive iterations. So you can see I've got fewer and fewer items here because like customer, I have a customer address, customer password. I can actually embed all that into a single customer document, if you will. And then here you can see, right? Cosmos is JSON data. So I can embed data. I can have arrays inside there. I can embed other objects like a password object or entity in there. And then I'll just show you the end result is I have a database that's got basically 4 tables or 4 containers, if you will, in there where I've merged and embedded all this data together. And then this is for change feed, which I'll show you in a minute. What I wanted to show you first, though, is the simplest thing you can do when you get started is you want to write queries for your data as you start figuring out how your app is supposed to work. And so where's the execute on here? This screen got all messed up here. Just take and kill that and here.
And just to answer Kev's question here, are all these links available? You can get them all in the YouTube chat right here in the Azure DevOps chat. You can also do it in my channel. All the links are going to be in there. And then there's going to be a show notes blog post that will come out on dev.to shortly after when this is finished. So you'll be able to get all the links and stuff that Mark and I are sharing today.
Yep. So here I just wanted to show a simple query, because one of the things you want to do is as you figure out what operations you're going to do on your data, some of them will be queries. And it's important to measure the cost of those queries, the throughput or the RU in there. So here I just have a simple query. I'm just looking up a customer. But what I wanted to show you is if you click on the query stats, you can actually see how much that query cost. And this is important because when you're trying to figure out, okay, how much throughput do I need? One of the things you need to do is figure out, okay, how many operations am I going to be running per second, and what operations are those? So if I'm looking up a customer and I'm doing it 10 times a second, then I need 30 RU just for that operation, right?
Do you mind if I share the RU slide, Mark? And maybe we can just touch quickly on it.
On an RU, sure.
So we're talking about request units. And request units are kind of like, we think of reservations in a way for our virtual machines and some other services. This isn't necessarily like reservations, but it's getting us close to understanding what our costs will look like long term. Am I right?
Yeah. So here's the thing: is RUs provide kind of a common way to define different physical resources that you're using, right? Like when you provision a VM, you have to know, okay, how many cores am I getting, and how much IOPS can it produce or use, and all those other kind of physical measures. we're a multi-tenant service, a database service. So we don't talk about those things. We want to abstract all that and provide kind of a unified way of being able to represent some unit of work within Cosmos. And so that's why we have this thing called a request unit, which is essentially a proxy for CPU and memory and IOPS within Cosmos. And every operation costs a certain number of RU, and that remains consistent within Cosmos. So as I go and I measure how many RU I need for that query, then good. Now I can note that and then understand how many of those queries I'm running a second, and then add on the other operations that I'm going to be running concurrently to help me come up with a ballpark for how much throughput do I need to run this database, right, for my app. And then, of course, this is just an estimate. Really, what you want to do as you get closer to going into production is put this thing under load and then measure. How much are you actually using, right? So start running your actual integration test and putting user load on these things. It's kind of part and parcel for how you should build for the cloud, right? But this is this capacity planning basically that people should be familiar with doing. So that's anyway. Here's query stats. I just wanted to show you this. So queries is one way you can retrieve data out of Cosmos, but actually most people are going to be writing code to doing that. And so they're going to use our SDK. And so I've got just some demos here that I use for this modeling talk. And I just wanted to show you kind of here's what code looks like when you're using our .NET SDK. So here I have a function query customer. This is going to query that same customer. So to do that, I need to get a reference to my database, which is this database here, and then a container, which is my customer container. And then I have this customer ID in a string, and I would probably pass this in in a real production app, and then a query SQL string in here, right?
Oh yeah, simple SQL query right there, very very basic.
Right. And then I got a parameter here, right? And then this function here, get item query iterator, is how I construct my query. Now the things you need for this function here are three things. You need the query text itself. You then need to pass in one or more parameters in there, right? And then the last thing is your partition key, right? Now, remember earlier when I talked about us being horizontally scalable, right? That partition key basically provides a routing or an address, if you will, for where your data sits, on what partition or what server does that data sit on. So if this is what helps make queries efficient. For things like Cosmos DB, because if I can tell you where that data, what server that data is sitting on, then I don't mess around having to hit every single server in my database to find the data I'm looking for, right?
Gotcha.
Here's a key thing that users don't understand that are new is when you're measuring, and you can measure the performance of this. Like if I pass this thing and I did not pass in a partition key, it's going to be more expensive. It's going to cost more RU. But here's the thing, you don't realize how bad the performance or cost is going to get until you actually get into larger numbers. If you have a small database and it's just running on a single partition, your queries are going to be fast and they're not going to cost very much. It's not until you actually start to scale out that you realize, oh no, I picked a terrible partition key because my queries either don't use it or for some other reason I'm not getting the performance and I can't scale out for what I'm trying to do. So understanding this access patterns and these usage patterns and picking a good partition key is super important. So anyway, just keep moving here on the code. So I've got, I'm going to run this query and then I'm going to run it in a while loop and just check if I have more results in there. And then I'm going to pass that to my response object. And then within that, I can iterate through the response object to grab all the customers if I had more than one. Now, in this case, I'm just querying for a single customer. So as I run this here, you can see here's my single customer. And in this case here, I'm using the V2. So I'm showing, here's my my data with an array of addresses in here and then a password object. And then there's the request charge 2.83, which is what I had before in there. So that's a query in there. And this is great if you want to run, you want to fetch rows and rows of data. And here I'm only requesting a single row. But here's another thing I want to show you is if you're just looking up a single item of data, we have this other function called read item async. And this executes what we call a point read in Cosmos. And to do a point read, you need just two things. I need the partition key for that data. So what server, what partitions that data sit on. And then I need the ID for that data. Within every partition, the ID is unique within there. So this is essentially the most efficient way you can read data from Cosmos DB is using this thing called a point read. So if you're looking up a single record and you know the partition key and the ID for the value, use a point read instead. And let me show you. If I do a point read here, here's the same data, but the RU, the request charge, is always 1, or is going to be 1. And in fact, for any data that's a kilobyte or less, your RU cost is always going to be 1 within there. So that's the super efficient way. I can't tell you how many customers I've seen that were doing high volumes of reads using a query. And the reason is simple. When you're doing a point read, you're essentially you're skipping right past the query engine and going straight to the backend store and grabbing that data. Because our backend store understands those two things, like what partition am I on and the ID for that data within there.
So I want to remind everybody, we got about 15 minutes left in the show. Just 15 minutes, man. This thing flies by so fast. And so I want to hear from all of you. I want to hear questions. I want to know what you're thinking about all this so far. And we've got a question. And so do you think there's an estimate ETA for that Cosmos DB serverless service to go GA?
Yeah, we haven't announced a date on that yet, and I'm not going to make any news here today.
Yeah, I know what that's like.
We're still in preview on this thing. We want to get it to the right quality bar, and we want to get enough users kind of using it in preview there so that we can just make sure everything's nice and smooth for G on there. So I don't have a date, but we do
check here the blog
to use it.
I've got the blog URL up, and so I'd assume that, along with standard Azure announcements that come on the Azure.com website, you can always check out the dev blogs and see all the Cosmos DB content, especially with Microsoft Ignite coming up. I'm going to guess that you've got some stuff coming up. I don't know. I just know what Ignite is like for everybody. And so, make sure, everybody, that if you've got a chance to register for Ignite, you go ahead and do that, because it's one of the better events that Microsoft provides, and it's virtual, it's online, it's free. I think you're going to have a good time. I know I'll be watching stuff. I'm looking forward to the big keynotes like Satya. Abel is going to be on there, probably Donna Sarkar, and of course Donovan. We've got so much really interesting stuff coming up, and so I want everybody to remember, head over to myignite.microsoft.com, register today, and be part. Because, like I said, if you want to see a lot of the new things that are going to happen, it's one of the best places to do so.
Yep. Yeah, we got some stuff. We'll be there next week, so definitely people should go check it out. Another thing I want to show you. So back to kind of the operations here. So I talked about point read, and you need a partition key and an ID for that. All of the CRUD operations are essentially the operations that look just like that. Like when you insert an item, you need a partition key and an ID in there. Same when you do an update in there as well, and a delete. So let me show you some others. So here I've got, and I actually want to talk to you about one more thing, which is I'm going to talk about change feed. So in the lower half of the window here, I have change feed, and this change feed is listening to one of the containers, my product category container in here. And what I've done in this model that I've set up here is I've modeled this data such that I'm denormalizing product category data into my products container. Because when I query for products, I need the product category name in there. Now, one of the problems with that is that you have to maintain referential integrity between my product categories in that container, and then the denormalized data sitting in product, so that it stays in sync. So, like, say if I updated a product category name, and in this example here, I'm going to update this category accessories, tires, and tubes, and I'm going to replace the word "and" with an ampersand. And then I'm going to call this function called replace item async. And this is basically how you do an update for data in Cosmos DB. and I'm going to pass in, well, I'm just using a hard code name for category for my partition key. But here again, the ID, and then here's my item, my updated category item here, right? Product category. Now I want to show you change feed. So I got change feed processor running here. And then this is what change feed looks like. So in my code here, and let me see if I can stretch this out a bit. So let me show you a couple things here. First thing is I have a reference to something that's called a lease container in there. And this basically provides kind of a checksum or a checkpoint on this. So as change feed runs, say every second here, it's going to check to see, is there any new data in there? And then match it up with the last time it ran. And if there is, then great. What it does is that it calls this delegate, which is defined as input here, and it's on my product category container, right? And then it'll run like every second here. And if there's new data in there, it's going to iterate through it. And then I'm going to read out of this input delegate here into a product category item. And then I'm going to pull out my category ID and my new category name. And then I'm going to call another function in here called update product category name. So I've got another function down here in my change feed. And this is going to get called every time I update the product category name in that other container. And I'm going to run another query here to go, what is this one? This is looking up all the products for that category ID.
And it's waiting for updates, essentially. It's waiting for changes.
Now I've got my category ID, two pieces of data to update product table. I got my category ID, which is how I partitioned my products container. And then I got my new category name. So I'm going to write a query here that's going to grab all the products with that category ID. And then I'm going to loop through it. And then I'm going to change the product category name for every product and then call replace item async. So I'm going to update every product within there. And so let me show you when I run this, how this looks. So put you back over here. Okay, so I'm going to update product category name here. Okay, so I've got 11 products in my product table. That's this category name. So now I'm going to update it. And now look down below, change feed will fire here. See, one change received, and now it's called update product category 11 times. Or it's called it once, but it's iterated through those 11 products and called that replace item async 11 times. So now that query is accessories, tires, ampersand, tubes in there.
Gotcha.
And that's how you maintain referential integrity from, say, master data to your denormalized data, which I want to do because I run the query for products a lot in this database, right? Like every time I hit a new category, new page, I'm running a query to give me all the products for that thing, and then I display them for the user, right? So they can look at that. So here I'll just change it back, and you can see it again. So this happens quickly within there. So that's change feed, and you can do change feed to do, all kinds of stuff. Let's say if you have a container and you query it a lot, but you use a different partition key value, you can actually use change feed to maintain two copies of that data in two different containers with two different partition keys. And this is kind of, weird to maybe a relational developer or people that are not used to this type of database. But in a NoSQL world, this is actually quite a common thing to do. And the thing to keep in mind here is, excuse me, in a NoSQL database, you don't care about optimizing around storage, right? Like storage is cheap. Excuse me. Storage is cheap. It's the compute that's actually the expensive thing.
Doing the processing of the data out of the database or into the database, and especially queries. If you have a complex query, obviously you're going to need enough compute to accomplish that, and that's going to cost you.
Yeah. So I want to show you one last thing, and that's transactions in here. So we have this new feature called Transactional Batch in Cosmos DB, and I want to show you how that kind of works. So I've got a customer table where I maintain a count of how many orders that customer has made. Now, all of my customers and my sales orders, I store in my customer container. And the reason is because both customers and sales orders have the same partition key, which is customer ID. So my logical partition has one customer document and then all of their sales orders within there. what this does is this lets me put a transaction around when I add a new sales order that allows me to both simultaneously update the number of sales orders they've made every time they create a new sales order. So here what I'm going to do is I'm going to get do a point read on my customer object, and I'm going to put it into deserialize this into my customer object here. And then I'm going to call customer.salesorderCount++, and I'm going to increment the number of sales orders that's in that value right there. And then here below, I'm going to create a new sales order. So I got a sales order object here, put in a bunch of 2 items into my sales order details. And then I'm going to use this cool new function we've got called Transactional Batch. And the syntax for this is really straightforward. I got my container object, and then I'm going to .create transactional batch. And then I'm going to pass in my partition key, right? Because I need my partition key for this. This is all scoped to a logical partition to do this transaction. And then I can call multiple items on here. I can create an item, right, with my new sales order. And then I'm going to call replace item, which is basically that update again. And I'm going to pass in the customer ID and my updated customer object that has the new sales order or count for sales orders. So let me quickly show you this. So I'm going to run create sales order and create it successfully. And now I can query for my customer, and I can show you, I should have run this one first, but here's my customer object and then sales order count. And then here's all their sales orders within here. So I can query that all the time. Let me do this. I'll delete that order. Let's just say, oh, I didn't mean to do that. And then let me query for that customer, same one. And here you can see their sales order counts now too, right?
Oh, there you go.
So and by the way, when I deleted that order, I used also transactional batch, right? It was the same thing. So here I've got transactional batch, and then I'm deleting my order and then doing an update on my customer in here.
Very, very cool.
Right?
I have a question because we're running up on it, and we got a question from Kevin. And Kevin wants to know, what would be the top couple of use cases for using Cosmo versus SQL for that backend DB? Like if you're using making a mobile Xamarin app, does it really depend on like what your backend database is in this case?
So there's multiple reasons to use a database like Cosmos versus a relational data store. One, availability is typically a reason why people want to use it because it's a distributed database. Cosmos can survive regional failures or outages. Another reason is latency. If you can get your data closer to your users, then the length of the time that it takes to do a request for a read is shorter because the packets don't have to travel as far. If you use our multi-master or multi-region write feature in there, and all of your replicas or all of your regions also accept writes, then your reads and writes are now really fast as well. So that's another reason is latency, not just for reads, but also for writes within
Very
there.
cool.
Being schemaless is another potential reason within there as well. So yeah, I mean, there's lots of reasons. It's not, I think you just have to kind of evaluate it and see if it makes sense. But those are typically it's availability and latency are the two big.
And I know mobile is a super common use case. I've seen a bunch of people use non-relational data in their mobile because of speed, throughput. But anyway, Mark, we're just up on it, and I wanted to go ahead and kind of give you a chance to roll out of this and give any other information. We talked earlier about Azure Cosmos DB Conf. Is your CFP open, or you're still looking for people to contribute?
We got a bunch of sessions in there. If people want to submit for a session for there, yes, feel free. But you don't have to. We'd love to have people join us. We'll have 3-hour streams. You can actually go to that URL there and get a save the date in there, or you can just RSVP by clicking a link and just you just put in your email, and then we'll remind you that way as well in your inbox. And then just come back to that page the day of, and then we'll have the live streams up there. And then we'll have everything up on demand as well, up on our YouTube channel as well. So if they miss the sessions, and each of those different 3 streams is going to have new content in it. So we'll repeat like our keynote and then just have new content each one in there.
Very cool. Well, hey, Mark, let's say a big goodbye. Thank you so much for being part of this today.
Yeah.
Obviously, right down below is where you can find Mark on Twitter. So great to have you part of this. Thank you so much.
You bet. Thanks, Jay. Great being here.
Great. So, everybody, we're going to give you the big wave goodbye. Have a great day. We're going to catch you next week. See you then. Thanks for watching.